Hi, this is Jade. First, I want to say thank you for your support on my previous video. A special thank you to all those who subscribed. Today, let's learn how to find range of functions, but first, let's introduce functions. A function relates an input to an output. The input is a set, the output is also a set. The input set is called the domain. The output set is called the range or image. For example, we have a set X with input elements 1, 2, and 3. We have another set X squared with elements 1, 4, 9. This set is the output set. The relationship between X and X squared, that is between the input and the output, is called the function, and it is denoted by f in this case. In notation form, we write it f maps x onto x squared, or f of x is equal to x squared. Therefore, f of 1 is equal to 1 to the square is equal to 1. F of 2 is equal to 2 to the square is equal to 4. F of 3 is equal to 3 to the square is equal to 9. Important note, one-to-many relation does not exist in functions. Therefore, one input cannot have more than one output. For example, f of x is equal to square root of x is not a function because let's say we try x is equal to 9. F of 9 is equal to square root of 9, which is equal to plus or minus 3. So we have two outputs. Hence, f of x is equal to square root of x is not a function. Now, how to find range? To find range, we sketch the graph of the function. For example, given f of x is equal to x squared, for x is an element of R. So f of x is equal to x squared is the function, and x is an element of R is the domain. Therefore, we have to sketch the graph of y is equal to x squared. Then our range is equal to the set of y values. To understand this better, let's try to find the range for two examples. Example 1. Given f maps x onto 2x plus 1. For x is between minus 2 and 3. Find the range. F of x is equal to 2x plus 1. Let y is equal to 2x plus 1. To be able to sketch our graph, we need two coordinates. Let's use the x is equal to minus 2 and x is equal to 3 from our domain. When x is equal to minus 2, y is equal to 2 times minus 2 plus 1 is equal to minus 3. And when x is equal to 3, y is equal to 2 times 3 plus 1 is equal to 7. So we have two coordinates, minus 2, minus 3, and 3, 7. Now we draw our axes, x and y, and then we input the two coordinates, minus 2, minus 3, and 3, 7. Since minus 2 is less than x, but it is not less or equal to x, we use an empty circle to represent the coordinate minus 2, minus 3. On the other hand, since x is less or equal to 3, we use a filled circle to represent the coordinate 3, 7. Now we join these 2 points with a straight line. Clearly, our y values are from -3 to 7. Range is equal to round bracket because -3 is not included in our range, comma 7 square bracket. Square bracket because 7 is included in our range. Now let us try example 2. We have to find the range of a quadratic function. Note, y is equal to ax squared plus bx plus c can be reduced to the form a bracket x plus d to the square plus e by completing the squares, as we have learned in our previous video. Now, if a is greater than 0, that is, if the coefficient of x squared is positive, then we have a minimum curve with minimum point minus d e. That is, our x value of our minimum point is minus d, and our y value of our minimum point is e. If, however, a is less than 0, that is, a is negative, then we have a maximum curve with maximum point minus d e. This note will help you when sketching a graph for any quadratic function. So our example 2, given f maps x onto x squared minus 6x plus 7, for x is an element of R, find range of f. Fx is equal to x squared minus 6x plus 7. Let y is equal to x squared minus 6x plus 7. A, coefficient of x squared is 1. B, coefficient of x is minus 6. C, constant is 7. Y is equal to x squared minus 6x plus 7 is equal to x squared minus 6x plus b over 2a to the square minus 6 over 2 times 1 to the square is equal to minus 3 to the square. So we add minus 3 to the square and we subtract minus 3 to the square, and of course plus 7 is equal to, now x squared minus 6x plus minus 3 to the square becomes x minus 3 to the square minus 9 plus 7. So x minus 3 to the square minus 2. Now since a is equal to 1, which is positive, we have a minimum curve with minimum point 3 minus 2. Because remember, the minimum point is minus d e. Now secondly, we have to find the y-intercept, that is, the point where x is equal to 0. Y is equal to x squared minus 6x plus 7. Y is equal to 0 to the square minus 6 times 0 plus 7 is equal to 7. Our y-intercept is 0, 7. We draw our axes, x and y, and then we input our two coordinates, 3 minus 2, which is the minimum point, and 0, 7, which is our y-intercept. We join the 2 points to make a minimum curve. We see that our y values are from minus 2 to infinity. Range is equal to square bracket minus 2, comma. Why we used square bracket this time? It's because in our domain, x is an element of R. So range is equal to square bracket minus 2, comma, infinity, round bracket. Why round bracket? When we put infinity or negative infinity, we always use round bracket because we don't know the exact value. Here it is, we have found the range for this quadratic function. If you liked this video, please be sure to give it a thumbs up. Join me in the comments down below and support my channel by subscribing. Thank you. Take care. See you soon.